It's almost certain there's going to be an influenza pandemic sometime in the future. It may not be the dreaded bird flu, which is around at the moment, but it'll certainly be some virus. There'll be no vaccine, but it'll take probably 6 months to produce. I mean, the only defence we'd have would be antiviral drugs, and this exhibit shows how the two drugs which are available were created and how they should be used.
I think one of the most important things about being here is to explain to people how these drugs work. A lot of people have come and said, oh, those drugs, they're old-fashioned, they don't work, do they? And the thing is, these drugs do work, they're very effective, but you have to take them very early on in an infection, ideally within the first 6 to 12 hours of getting any symptoms. And that's something that people don't realise. If you take them too late, they don't work, because they don't actually kill the virus, they just contain it within a few cells, and if too many of your cells have the virus, then it's too late.
The exhibit we're showing today shows how the antiviral drugs Tamiflu and Relenza, that are stockpiled by the government to treat a potential influenza pandemic, were actually designed knowing the 3D molecular structure of surface proteins on the influenza virus.
Basically, we took swabs from...
The technique that I work on is protein crystallography, and it's a method that's used to derive the 3D structure of molecules, potentially on viruses and bacteria, so that we can design drugs that will inhibit their interaction with human proteins.
The really great thing about those drugs is that they'll work against any type of influenza, so no matter how...
Half the team are in Australia, half the team are in the UK. We use the team in Australia to collect samples of the virus, and then the team in Britain does a lot of the crystallography work.
The process that resulted in the design of these drugs has happened as a result of work that's gone on over the last 50 years. And one of the very important steps is being able to visualise a three-dimensional structure of one part of the virus that's vital for it to survive within an infected individual. And being able to see what this particular part of the virus looks like has enabled scientists to design drugs that stop it from working and therefore contain the virus within a few cells of the body, which your immune system can then deal with successfully. What will happen over the next few years is that people will work out different ways of inhibiting this virus, so that if it develops a resistance to the drugs we have, then there are other drugs that we can use as a backup.